When running electrical wiring to a spa, the National Electrical Code (NEC) specifies acceptable conduit types for use inside the spa cabinet. These conduits serve to protect the wires and ensure safe operation. Several options are available, including non-metallic flexible conduit (NFC) and metallic flexible conduit (MFC). Within the non-metallic category, liquid-tight flexible non-metallic conduit or LFNC is permitted. Armored fiber cable (AFC) may also be used. For metallic options, liquid-tight flexible metal conduit or LFMC is allowed, as is flexible metal conduit or FMC. Liquid-tight flexible non-metallic conduit (LFNC) is often favored for its flexibility. This allows for easy maneuvering around pumps, hoses, and other components inside the spa cabinet. It also provides excellent protection against moisture and physical damage, crucial in a spa environment. To ensure code compliance, it is important to select the correct size and type of conduit for the conductors being used. The conduit must be appropriately sized to accommodate the number and size of wires it will contain. For an installation involving 3 individual 6 American wire gauge (AUG) wires and 1 8 American wire gauge (AUG) ground wire, the conduit must have sufficient inner diameter. A formula can be used to calculate the minimum inner diameter (ID) needed. It is calculated as ID equals 2 times the largest conductor diameter plus 6% for layout. According to the NEC, the conduit should be securely supported along its entire length. This prevents sagging and potential damage. Ensure adequate slack is left at each end of the conduit to facilitate future maintenance and repairs. If the conduit passes through any walls or partitions, it must be properly sealed to maintain watertightness and prevent moisture intrusion. Always consult the latest edition of the National Electrical Code (NEC) and local electrical codes for specific requirements and regulations in area. Compliance with these codes is essential for ensuring the safety and proper functioning of the spa electrical system. When dealing with electrical work, consider consulting with a qualified electrician to ensure the installation meets all applicable codes and safety standards. They can help determine the most appropriate conduit type and size for specific application, as well as ensure proper installation techniques are followed. Additional considerations should be taken into account when selecting and installing conduit for spa wiring. Firstly, ensure the conduit is listed and labeled by a recognized testing laboratory such as Underwriters Laboratories (AL) or Electrical Testing Laboratories (ETL). This listing indicates that the conduit has been tested and meets specific safety standards. Secondly, consider the ambient temperature inside the spa cabinet. Some conduits may have temperature limitations, so it is important to choose a conduit that is suitable for the expected operating temperature. Thirdly, pay attention to the bending radius of the conduit. Flexible conduits have a minimum bending radius that should not be exceeded to avoid damaging the conduit or conductors. Consult the manufacturer's specifications for the minimum bending radius of the conduit being used. Fourthly, when installing the conduit, use appropriate fittings and connectors that are listed for use with the specific type of conduit. These fittings should be properly tightened to ensure a secure and watertight connection. Fifthly, ensure the grounding conductor is properly installed and connected to the grounding system. This is essential for safety and to prevent electrical shock hazards. Sixthly, after the installation is complete, thoroughly inspect the conduit and wiring to ensure there are no signs of damage or defects. Test the electrical system to verify that it is functioning properly and that all connections are secure. Seventhly, keep a record of the installation, including the type and size of conduit used, the date of installation, and any other relevant information. This record can be useful for future maintenance and repairs. Eighthly, be aware of any local amendments or interpretations of the National Electrical Code (NEC) that may apply in the area. Local authorities may have additional requirements or restrictions regarding spa wiring. Ninthly, always disconnect power to the spa before working on any electrical components. This is essential for safety and to prevent electrical shock. Tenthly, if you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the installation. They have the knowledge and experience to ensure the job is done safely and correctly. Understanding the different types of flexible conduit allowed by the National Electrical Code (NEC) for spot wiring is crucial for ensuring a safe and compliant installation. By selecting the appropriate conduit type, size, and fittings, and by following proper installation techniques, it is possible to create a durable and reliable electrical system for SPA. Remember to always consult the latest edition of the NEC and local electrical codes, and to seek the advice of a qualified electrician if needed. The choice of conduit depends on several factors, including the degree of flexibility required, the level of protection needed, and the specific environmental conditions within the SPA cabinet. LFNC, liquid-tight flexible non-metallic conduit, is a popular choice due to its excellent flexibility and resistance to moisture and chemicals. It is also relatively easy to install and can be cut to length as needed. LFNC, liquid-tight flexible metal conduit, offers a higher level of mechanical protection than LFNC and is suitable for applications where the conduit may be subject to physical damage. FMC, flexible metal conduit, is another option, but it is not liquid-tight and may not be suitable for all SPA applications. When selecting a conduit, it is important to consider the trade size of the conduit. The trade size refers to the nominal inside diameter of the conduit and is typically expressed in inches or millimeters. The trade size of the conduit must be large enough to accommodate the conductors being installed without exceeding the conduit fill requirements specified in the NEC. The NEC specifies the maximum percentage of the conduit that can be occupied by conductors. This is known as the conduit fill percentage and is typically expressed as a percentage of the conduit's cross-sectional area. The conduit fill percentage varies depending on the number and type of conductors being installed. To determine the appropriate trade size of the conduit, it is necessary to calculate the total cross-sectional area of the conductors being installed. This can be done by using the conductor dimensions provided in the NEC or by consulting the conductor manufacturer's specifications. Once the total cross-sectional area of the conductors has been determined, the minimum trade size of the conduit can be calculated using the conduit fill tables in the NEC. In addition to the trade size of the conduit, it is also important to consider the type of fittings being used. Fittings are used to connect the conduit to electrical boxes, enclosures, and other equipment. The fittings must be compatible with the type of conduit being used and must be properly installed to ensure secure and watertight connection. There are many different types of fittings available, including connectors, couplings, elbows, and tees. The type of fitting used will depend on the specific application and the configuration of the wiring system. When installing conduit, it is important to follow the manufacturer's instructions and the requirements of the NEC. The conduit should be properly supported to prevent sagging or damage. Support should be spaced in accordance with the NEC and should be securely fastened to the structure. The conduit should also be protected from physical damage. If the conduit is exposed to physical damage, it should be protected by a guard or other means. The conduit should also be properly grounded. Grounding is essential for safety and to prevent electrical shock hazards. The grounding conductor should be connected to the grounding system in accordance with the NEC. When working with electricity, it is always important to follow safe work practices. These practices include disconnecting the power before working on any electrical equipment, using appropriate personal protective equipment, and following the instructions of the NEC. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge and experience to perform the work safely and correctly. Remember that electrical work can be dangerous, so it is important to take all necessary precautions. By following these guidelines, you can ensure that the SPA wiring is installed safely and in accordance with the NEC. This will help to protect yourself and others from electrical shock hazards and will ensure that the SPA operates safely and reliably. Furthermore, selecting the correct type and size of flexible conduit for SPA wiring within the cabinet is paramount for safety and compliance with the electrical codes. The National Electrical Code (NEC) provides specific guidelines on acceptable conduit types based on their material, flexibility, and resistance to environmental factors like moisture and chemicals commonly found around SPAs. Flexible conduits are particularly useful in spa installations due to the confined spaces and the need to navigate around pumps, heaters, and plumbing. Among the approved options, liquid-type flexible non-metallic conduit (LFNC) often emerges as the preferred choice for its superior flexibility and resilience against moisture and chemical exposure. However, liquid-type flexible metal conduit LFMC is also suitable, especially in scenarios demanding enhanced mechanical protection. Flexible metal conduit FMC represents another alternative but might not offer the same level of protection against moisture as LFNC or LFMC. The correct sizing of the conduit is equally crucial to ensure it can safely accommodate the conductors without exceeding fill capacity as dictated by the NEC. For a wiring configuration consisting of 3 6 American wire gauge (AUG) wires and 1 8 American wire gauge (AUG) ground wire, one must calculate the minimum inner diameter (ID) of the conduit to meet code requirements. A common formula for determining this is ID equals 2 times the diameter of the largest conductor plus 6% for layout space. Always refer to the NEC tables and guidelines for specific fill percentages and conductor dimensions to ensure accurate conduit sizing. Proper installation practices are as vital as selecting the right materials. The conduit must be securely supported at intervals specified by the NEC to prevent sagging and potential damage. Leaving sufficient slack in the conduit at connection points facilitates future maintenance or repairs without stressing the wires or connections. When the conduit traverses walls or partitions, sealing it appropriately ensures a watertight barrier, preventing moisture from seeping into electrical components. When working on electrical systems, prioritize safety by disconnecting the power source before commencing any work. This precaution minimizes the risk of electric shock and ensures a safe working environment. Employ appropriate personal protective equipment, PPE, such as insulated gloves and safety glasses, to further mitigate potential hazards. Verify that all materials, including conduits and fittings, bear the mark of a recognized testing laboratory like Underwriters Laboratories AL, indicating they meet established safety standards. Adhering to these guidelines not only ensures compliance with electrical codes but also enhances the safety and longevity of the spa's electrical system. If uncertainty arises or the complexity of the installation seems daunting, consulting a qualified electrician is always recommended. Their expertise guarantees the job is executed safely and in accordance with all applicable regulations, providing peace of mind and a reliable spa operation. Lastly, always consult the most recent edition of the National Electrical Code, NEC, along with any local electrical codes or regulations. These codes provide detailed requirements for electrical installations, including spa wiring, and are regularly updated to reflect new technologies and safety standards. Stay informed about the latest code requirements to ensure compliance and safety. The National Electrical Code, NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and maintained by the National Fire Protection Association, NFPA, and is widely adopted by state and local jurisdictions. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for anyone involved in electrical work to be familiar with the NEC and to follow its requirements. Local electrical codes may also have additional requirements or restrictions that must be followed. These codes may be more stringent than the NEC and may address specific local conditions or concerns. It is important to check with the local authorities to determine the applicable electrical codes in your area. In addition to the NEC and local electrical codes, there may also be industry standards or best practices that should be followed. These standards may provide additional guidance on specific electrical installations or equipment. It is important to stay informed about the latest industry standards and best practices to ensure that your electrical work is safe and reliable. When working with electricity, it is always important to prioritize safety. Follow safe work practices, use appropriate personal protective equipment, and disconnect the power before working on any electrical equipment. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge and experience to perform their work safely and correctly. Remember that electrical work can be dangerous, so it is important to take all necessary precautions. By following these guidelines, you can ensure that your electrical work is safe and compliant with all applicable codes and standards. This will help to protect yourself and others from electrical shock hazards and will ensure that your electrical systems operate safely and reliably.